So you are able to see the screen also.
Yes, sir.
We will begin our lecture by solving some numericals based on the first law of thermodynamics applied to open system, applied to closed system. So if you remember the formula for uh, open system we had, yes, anybody would like to recall about the formula for open system? First law applied to open system. Basic formula for thermodynamics is what? Summation of Q is equal to summation of W. But then it gets modified as summation of Q minus summation of W will be equal to delta U. That is the change of internal energy. Then we also talked about application of this first law to some processes, which is a constant volume process, constant pressure process, constant temperature process, that is called as isothermal. Then PV is equal to constant, right? PV raised to gamma is equal to constant, which is isentropic process, and so on. Okay. Now, based on that, we will see some example. We will look at the example. You see that I will read out the question in a cylinder piston arrangement. So, cylinder piston arrangement, the pressure is inversely proportional to the square of the volume. What it is given? Pressure inversely proportional to square of the volume is given. The initial pressure in the cylinder is 20 bar, P1 20 bar, and the initial volume is 0.1 meter cube, V1 0.1 meter cube. Volume is increased so that final pressure reduces to 2 bar. P2 is 2 bar. Find the work done in kilojoule. W from 1 to 2 is equal to question mark. Isn't it? Is what the question is? Understood the question?
Yes, sir.
Right. So how to proceed now? How to proceed for this question? You have the given data as, so what is the if you want to convert 20 bar, okay, what you will write in terms of Newton per meter square? So always remember 20 into 10 raised to 5 Newton per meter square. This will be equal to 2 into 10 raised to 5 Newton per meter square. Is it okay? This conversion you must know. Okay. This is also called as Pascal. Newton per meter square is also called as Pascal. Okay. Is also called as Pascal. P is proportional to, inversely proportional to 1 by, and what is the work done given by? Work done is given by, can anybody tell me expression for work done? If it is a P into dV work now, so work done is equal to integral of 1 to 2 P dV. Yes or no?
Yes, sir.
Right. So P is proportional to 1 by C. So can I write that is P is equal to some constant upon V square? Yes or no? So I will substitute that over here. Will be equal to, in place of P, I will write integral 1 to 2 C by V square dV. Okay. So C will come outside 1 to 2 1 by V square dV. So what we can write for how we integrate 1 by V square? Integral 1 by V square. It is 1 upon x raised to n. What we write? X raised to n minus 1 है ना? Or it is V 1 upon V square, we can write it as V raised to minus 2. Right? So it will become V2 and V1 at 1 to 2, and minus sign will come outside. Or we can write, just arranging the term. What is the value of C from here? From here, what is the value of C? C can also be written as
PV
C is
square.
PV square. That is P1 V1 square, which is equal to 20 into 10 raised to 5 into 0.1 square. Is how much? 20,000, right? So W will be equal to 20,000, because it is V1 is given. If V2 was given, then we could have calculated V2 also, and we could have calculated the same thing will come as C. So C is PV square, P1 V1 square is also equal to P2 V2 square. Okay, so we have to calculate first the value of V2, then only we will get the value of work done. Okay, so from here we will calculate the value of V2 also. So C is also equal to P2 V2 square. Okay, so therefore V2 will be equal to square root of C by P2. What is C? C is 2000. So 2000 or 20,000 divided by 2 into 10 raised to 5. That is 0.31 meter cube. So then W will be equal to 20,000 1 by 0.1 minus 1 by 0.31. Okay, and this is equal to, so 135.4 into 10 raised to 3 Newton meter. Okay, what is Newton meter? It is, Newton is what? Can I write it as joule per second square? So
Yes, sir.
yeah, so this will become, so W will be equal to just 135.4 kilojoule. Okay, so this is the answer. Just see what we have done. Just to summarize, we have read the question and we understood that there is some relation between pressure and volume. So we have done for the relation for pressure and volume as P is equal to constant, V is equal to constant, PV is equal to constant, which is isothermal process. Then PV raised to gamma is equal to constant. Then PV raised to N is equal to constant. So all these things are known to us. Just find out the relation of the question, relation what the question is saying. Here the relation was given as P is inversely, volume is inversely, pressure is inversely proportional to square of the volume. So P is inversely proportional to 1 by V square, that relation we have obtained, or it was given in the question. We found out the values. Only conversion factor, this is very important. How this 20 bar gets converted into this, we have done it in lower semester, so we are not going deep into it. That how this came. Okay, then we just by work done, we know a work done is given by integral of P dV. So we know the relation between P and V. So we calculated this. Any doubt in this question for anyone?
सर
Yeah.
सर इंटिग्रेशनचे लिमिट्स आपण सबस्टिट्यूट नाही केले.
इंटिग्रेशनचे
लिमिट्स
लिमिट
1 to 2
केले ना आपण. इकडे हे बघ, आता हे दिस इज व्हॉट x raised to minus 2. So what we write? X raised to minus 2 plus 1, right?
हाँ सर.
Right. So and minus 1 will come outside, है ना?
Yes sir. Okay.
So this substitution is done over here, that is x, but then this 2 will come here. So 2 minus 1, like this. This substitution is done, and because it is minus sign outside, so v2 will come in this side. That v2 raised to minus 1 is nothing but 1 by v2. So minus 1 by v2, minus 1 by v2, and plus 1 by v1. So that we have arranged here. Is it okay?
Yes sir.
Right. Any doubt for anyone? We'll move forward.
सर स्टिल डिडंट गॉट दैट स्टेप कि वहाँ पे v2 एंड v1 कैसे आया. मतलब अगर हम लोग इंटीग्रेट करेंगे तो वो v तो v ही रहेगा ना.
हाँ, ये जो लिमिट्स है ना, ये 2 to 1, 1 to 2, ये हम लोग
Yes, sir.
सब्स्टिट्यूट कर रहे हैं. फाइनल माइनस इनिशियल ना.
हाँ ओके ओके समझा.
समझा ना? बेसिक मैथ्स. Is it okay?
Yes sir.
Okay. Right. So we will move further to the next question. Volume of, now you try to do this in your notebook. We will then cross check if you are getting the right answer or not. So everyone, I will request everyone to do it in the notebook. Is it okay? Volume of sample of gas is 0.04 meter cube and at a pressure of 10 bar. Now you know 10 bar is nothing but 10 into 10 raised to 5 Newton per meter square or Pascal. If the final volume of the gas is 0.1 meter cube. Okay. Meter cube. Then what will happen? After following process, after the following processes were carried out, evaluate the work done. So two conditions are given. Constant pressure process, if it is there, then what will be the work done? And PV is equal to constant means this is which process? This is which process? PV is equal to constant is which process? If this constant pressure process is nothing but
constant
Sir,
temperature.
isothermal, correct? Yes.
Constant temperature.
Constant temperature, yes, very good. Isothermal process this is. So by looking at this, what do you feel? कौन सा प्रोसेस ज्यादा वर्क डन देगा? आपको क्या लगता है? जस्ट अ प्रिलिमिनरी इंट्यूशन. Constant pressure process will give me more work, or isothermal process will give me more work? What do you say?
Constant pressure.
Correct. Constant pressure will give me more work. Why? Because it is integral of PdV. Integral of PdV. So you see, when the constant pressure process is there, you can have area under the curve as this. Yes or no? Whereas if it is isothermal process, my curve goes like this, and area under the curve is lesser. Okay? Area under the curve is lesser. Okay, no problem. We will solve it and then we will see. So we will first consider constant pressure process. Okay, so basic equation is work done is equal to integral 1 to 2 P dV. P is constant. So what it will be? Only dV. Yes or no? So what will be integral of dV? P outside integral dV. That is nothing but integral dx. Integral dx is x. Yes or no?
Yes.
So that will be equal to 10 into 10 raised to 5 in the bracket final minus initial. Yes or no?
Yes, sir.
So this is how much? You are getting the same thing?
सर डीव्ही म्हणजे चेंज इन व्हॉल्यूम.
dV means change in volume. Yes.
मग त्या 0.1 मायनस 0.4चं आपण इंटिग्रेशन घेणार.
नाही. 1 minute. Integral x dx is what? X square.
एक्स स्क्वेअर.
Integral dx is what? X. बराबर?
येस. हा सर बरोबर.
So integral dv will be equal to v. If I integrate from 1 to 2, then this will be written as 1 to 2. Means v2 minus v1. Yes or no?
येस सर.
So what is v2? v2 is final volume. Final volume of the gas is 0.1 meter cube and initial volume of the gas is 0.04 meter cube. So we are substituting is, so here it should, one step will be what? P integration we have done, so it will become V 1 to 2. That is nothing but P V2 minus V1. Yes or no?
Yes.
So that is nothing but this P, which is the pressure, and this is the difference of volume. Is it okay?
येस सर गॉट इट.
Yes.
Got it now? So next one I want from your side. Okay, next one I want it from your side. So let us see who is able to solve. Yes. So we will have now second. Second is PV is equal to constant. PV is equal to constant. This process. So we will have what we will have. P is equal to C by V. Barabar? So W is equal to integral of 1 to 2 P dV, which is equal to integral 1 to 2 C by V of dV. Correct? Right?
Yes, sir.
So what I will now write here, what will be integral of 1 by x dx?
log
What
x.
is integral of 1 by x dx?
Log x, sir.
Log x, barabar. Right.
Plus constant. Log x.
Integral 1 by x dx is log x. If it is from 1 to 2, then log of x 1 to 2. Yes or no?
Sir.
Correct? So now you tell me, this will become c log of
V.
v2 by v1. Yes or no? Log of v2 minus log of v1, which is log of v2 by v1.
v2 by v1.
Correct. And what is c? C can be written as pv. That means I can write it as p1 v1 or p2 v2. Yes or no? Is it okay? Why I am not writing p2 v2? Because I don't know value of p2. Here only pressure first, and pressure is given at initial pressure. Initial volume is known. So I will write p1 v1. This I can also write p2 v2 log of v2 by v1 is one and the same. Isn't it?
Yes, sir.
Yes? Yeah. So what is p1? Value of p1?
Sir, 10 into 10 raised to 5 Newton per meter square.
Correct. 10 into 10 raised to 5 Newton per meter square into v1. v1 is initial volume.
0.04 meter cube.
Right. And log of v2. v2 is how much?
0.1.
0.1.
Right. So if you solve this, what is the answer? Can you tell me?
36.65. 36.65 kilojoule.
Correct. So 36.65 kilojoule is okay.
Yes, sir.
So such kind of questions you can expect in your term test. Any doubt in this question?
सर
Yeah.
सर ऍक्च्युली कोणत्या प्रोसेसला कोणता फॉर्म्युला यूज करायचा ते ऍक्च्युली समजत नाही.
कोणत्या प्रोसेसला
कोणता वर्क डनचा फॉर्म्युला किंवा पीव्ही रेस टू गॅमा इज कॉन्स्टंट ते समजत नाही सर.
PV, okay, 1 minute. Yes, 1 minute. So initially we started with first constant pressure process. P is equal to constant. Isn't it?
Yes, sir.
No, initially we started with V is equal to constant. If you remember, V is equal to constant. If V is equal to constant, W equal to 0. Yes or no? Our third lecture. Because in our
Yes.
graph, see, work done is always given by integral of P dV. So if dV is not changing, work done will be equal to 0. Yes or no?
Yes, sir. Got it. समझ गया.
ये PV डायग्राम है. ये एरिया अंडर द कर्व कुछ नहीं है. There is nothing. So W equal to 0. Second one was pressure is equal to constant. In this case, our graph will be something like this. Yes or no? So area under the curve is this. So there will be some W equal to integral of 1 to 2 P dV. In place of P, it will be constant, so it will be integral dV. That means W will be equal to P1 V1. Yes or no? Is equal to P2 V2. है ना?
Yes, sir.
Then third one was PV is equal to constant. For PV is equal to constant, P is equal to C by V. If I do C by V, W will be equal to integral 1 to 2 P dV and in that case it will be integral 1 to 2 p के जगह पे लिखेंगे c by v dv. In that case w1 to 2 will be equal to p1 v1 log of v2 by v1, isn't it?
Yes, sir.
Third one, fourth one, pv raised to gamma is equal to constant. So p is equal to c by v raised to gamma. W will be equal to integral p dv, that is integral of c by v raised to gamma dv. Yes or no?
Yes, sir.
So W1 to 2 will be equal to gamma minus 1 upon gamma P1 V1 log of V2 by V1. Yes or no? This is what assignment I had given you to see for this is isentropic process. PV raised to gamma is equal to constant is isentropic process. Then fifth one was PV raised to n is equal to constant. So W1 to 2 will be equal to n minus 1 upon n P1 V1 log of V2 by V1. ओके, सो इतने 5 प्रोसेसेस है वो जो आपको याद रखने हैं. फॉर ऑल 5 प्रोसेसेस W will be equal to integral of P dV. This is only for non-flow system. For flow system, what is for flow system? Flow system, there is a equation called as steady flow energy equation. This is only for non-flow system. How to identify it is a non-flow system? How to identify it is a non-flow system? From this. In a piston cylinder arrangement means what? It is this way. इसके अंदर का जो वर्क, इसके अंदर का जो वॉल्यूम है, that is getting compressed and expanded. Yes or no? Whether that mass or whether that whatever the volume is occupied by this mass, whether it is leaving the system, yes or no?
No.
No, correct. Matter is not leaving, so it is a non-flow system. Yes or no? Non-flow system. अभी आपको पहले वाले सब लेक्चर्स याद आ रहे हैं? When I said non-flow system, okay. When I said flow system, and in that case, what was the flow system? Flow system में मैंने कैसे डायग्राम बनाया था? ऐसे डायग्राम बनाया था, if you remember, right? Then इधर कुछ तो मास था, that was getting pushed over here. Yes or no?
Yes, sir.
Yes, then we applied what? Steady flow energy equation. In that case, Q minus W shaft work will be equal to delta KE plus delta PE plus delta H. Yes or no? And there was one more term which is called as W flow work. You remember now?
Yes, sir.
Right. So remember this. Okay, remember this. Don't get confused with flow work and non-flow work. In the question, please read carefully. Find out if there is a, identify first whether it is flow work or non-flow work. Then identify whether it is what? Then identify whether it is what relation we get between pressure and volume. Identify these 5 relations. ये 5 relations आपको याद होने चाहिए. 1, 2, 3, 4, 5. कितना टाइम लगा मुझे ये लिखने के लिए? With these 5 relations, oh, hardly 1 minute or 2 minutes. So this should be your revision. This should be your revision, isn't it? Any difficulty in understanding this?
No, sir.
Correct. Okay, if you have difficulty, please speak. Don't keep it to yourself, because this first law will have some good amount of marks in term test. Now next question.
सर एक सेकंड ते नोट डाऊन
हाँ,
करून
बोला.
घेते. ते नोट डाऊन करायचं आहे सर, लिहिलंय तुम्ही ते.
Okay.
सर तुम्ही ह्याच्या अगोदरच्या लेक्चरचं सेंड नाही केलं रेकॉर्डिंग क्लासरूमवर?
मी करतो मी करतो ते. Is it okay? We'll move further. Okay, this question. A refrigerator is loaded with food and the door of the refrigerator is closed. Okay. So this is refrigerator space. Door of the refrigerator is closed, so it will become, this is my control volume. Space inside the refrigerator is my control volume. During certain period of time, the machine requires 1 kilowatt hour. How much is see, in order to compare between energies, all units must be same. Yes or no? So 1 kilowatt hour will be equal to how many kilojoules? Can somebody find it for me? How many kilojoules? Anybody doing?
So
Yes, sir. 1 minute.
If you remember, I told you watt is nothing but
Joule per second.
So
joule per second.
3600.
Correct. Yes. So 3600 kilojoule. How it came? Watt is joule per second. So kilowatt becomes kilojoule per second. 1 kilowatt hour. So we have to convert this into per second ना. किलोवाट की जगह पे हम लोग क्या लिखेंगे? जूल पर सेकेंड into this should be in second so that second will get cancelled. So 1 kilojoule per second. In place of kilowatt, I will write kilojoule per second into hour. The hour and second will not get cancelled. I want to get it cancelled. So instead of hour, I will write 3600 seconds. Yes or no? So these seconds and this second will get cancelled. So my answer is this. Is it okay? Right. So we got this 1 kilowatt hour is equal to 3600 kilojoules. Now what is next one? The machine requires 1 kilowatt hour. The energy of the system drops by 6000 kilojoule. Energy of the system drops by 6000 kilojoule. Refrigerator is work consuming device or work producing device?
Work consuming, sir.
Work consuming. And how much it consumes? How much it is consuming? This refrigerator is consuming how much amount of work?
1 kilowatt hour.
1 kilowatt hour means 3600 kilojoule. By consuming 3600 kilojoule, the energy of the system, what is system? System is this. The energy of the system drops by 6000 kilojoule. Barabar? Yes or no? So what is this energy? ये कौन सा एनर्जी है? हीट एनर्जी है या वर्क एनर्जी है? या कोई अदर एनर्जी है?
हीट एनर्जी.
The energy of the system drops by 6000 kilojoule. Find the net heat transferred to or from the system. If you remember, I told you internal energy is a property of what? System. So, and the relation between heat and work is nothing but change in internal energy. Yes or no? So we have to find net heat transferred. So we have to find Q. Q is question mark. W is known. And change of internal energy is here. System drops or increase है ना, ये आपका change of internal energy है. There is a change in system drops or system rises. Energy rises, energy drops, so it is a change. Always change is associated with internal energy. So internal energy is drops by 6000. So delta U is nothing but minus 6000 because it is drops. Now the units are same. We will get the value of Q as, so Q will be equal to delta U, that is 6000 minus, so work is consumed. Work is consumed by the, work is done on the system. So we will, so work done on the system, is negative, and work done by the system is positive. In some books you will find it reversed. No problem. In some books you will find it reversed, but no problem, answer will come same. So here in our case, W is also what? Work consumed by the system. So it is minus 3600 kilojoule. So here it will become delta U plus minus 3600. So it becomes minus 9600 kilojoule. So that means because it is minus, that is heat is rejected. Such kind of questions can come in question number 1, compulsory question for 5 marks. Just application of formula and calculation of application of formula and finding out the results. That's it. Is it okay?
Yes,
This
sir.
question is okay for you?
Yes, sir.
For everyone? In the chat section, please tell if you have any difficulty or you are not understanding the questions, numericals. So there are several numericals, around 7-8 numericals I will give you. You solve it. If you get some, if you find some difficulty, make a group of 3 students. Each and everyone will solve it, post it in the group, and see the compare the answers that you have got. If there is a variation in the answer, then you say what methodology you have followed. कि आपने क्या फॉर्मूला लगाया तो आपको ये आंसर आया, सबका आंसर सेम आना चाहिए, and then you get it learned. Okay, this is called as a collaborative learning. Okay, you have to this is okay, we will follow this collaborative learning. For this class I will send some questions to you. You have not formed any group. I have told you to form an unofficial group for thermodynamics. only for the subject of thermodynamics, so that we can share some questions. You solve it on your part. Do you want any question on steady flow energy equation? We will solve one problem on steady flow energy equation. What do you say?
यस सर,
एक क्वेश्चन सॉल्व करते हैं स्टेडी फ्लो पे.
यस सर.
Okay, very simple question I will give you related to steady flow energy equation. 1 minute.
सर या सम मध्ये पण आपण स्टेडी फ्लोच वापरलो ना.
या क्वेश्चन मध्ये स्टेडी फ्लो आपण नाही वापरला. इट इज अ नॉन फ्लो सिस्टम. इट इज क्लोज्ड. सी हियर.
सर हा ते पण सम साठी कुठलं टेक्स्टबुक चांगलं आहे? बिकॉज ते चार्ल्स मी बघितले ते कुठलं ते तुम्ही सांगितलेलं ना, मला नावाचं नाही आठवत. ते तुम्ही टेक्स्टबुक सांगितलं ना, ते मी बघितलं. त्याच्यामध्ये फुल थिअरीच आहे. सम्स भरपूर क्वचित दिसतात मध्ये मध्ये.
सेंजल मध्ये ना.
हा, सेंजल मध्ये.
So Angel is if you want to solve some numericals, no, basic numericals. If you want to solve, see the book name is Shom series.
स्पेलिंग चॅट मध्ये टाइप करा ना स्पेलिंग.
Okay, 1 minute. I also don't know the spelling. 1 minute. I'll just share it with you. So it's a book by Shom's Outline of Thermodynamics. I'll just write it. SCHAUMS. Shom's Outline for Thermodynamics. Don't buy this book. Just if you get some copy, just refer it. You can check it in library also. We have it in our library. मैंने मंगाया था. Shom's Outline for Thermodynamics. You can check it in our library. Okay. You have noted the name of the book,
Yes sir.
right? So we will solve one problem based on steady flow energy equation. So why don't you write it down instead of writing here? I will just dictate. You write the question. Is it okay, everyone? You can write the
Yes, sir.
question. Yeah.
येस सर.
Okay. So write down air at a temperature of air at a temperature of 15 degrees Celsius passes through a heat exchanger at a velocity of 30 meter per second, where its temperature raised to 800 degrees Celsius. Full stop. It then enters turbine with same velocity of 30 meter per second and expands until temperature falls to 650 degrees Celsius. Okay. On leaving the turbine, the air is taken at velocity of 60 meter per second to a nozzle where it expands until the temperature falls to 500 degrees Celsius. Okay. If airflow rate is 2 kg per second, this is the m dot. Okay, this is the m dot. Calculate rate of heat transfer to the air in heat exchanger, power output of turbine, okay, assume no heat loss. Third, exit velocity of from the nozzle. Okay, take value of H is equal to Cp into T, where Cp is equal to 1.005 kilojoule per kg Kelvin, and T is equal to temperature. Is it okay? So by reading the question, what it says that air at a temperature of 15 degree passes through heat exchanger. So first we have a heat exchanger. So this is my inlet, this is my outlet, and this is my system boundary. So this is first condition. Second condition. So air at a temperature of 15 degrees Celsius passes through heat exchanger at a velocity of 30 meter per second. So T is equal to 15 degrees Celsius. C1 is equal to 30 meter per second, where its temperature is raised to 800 degrees Celsius. T2 is equal to 800 degrees Celsius. It then enters turbine with same velocity. So C2 is equal to 30 meter per second and expands. So this is taken into what? A turbine. This is taken into a turbine. You know the symbol for turbine. What is the purpose of turbine? Turbine में क्या process होता है? Expansion in turbine. So inlet of turbine is 800 degrees Celsius and 30 meter per second. Outlet of turbine is T3 will be equal to 650 degrees Celsius. And what about the velocity of C3?
60 meter per second.
Correct. So C3 will be equal to 60 meter per second. This is taken into what? This is further taken into what?
Nozzle.
Nozzle. So we will have a nozzle. So inlet condition of nozzle is what? 650 degrees Celsius and 60 meter per second. What about the exit condition? In a nozzle where it expands until the temperature falls to 500 degrees Celsius. So T4 is equal to 500. If the m dot will remain constant, it is 2 kg per second. And what about C4? What is the exit velocity of the nozzle? That we have to find out. Yes or no? Right?
Yes, sir.
Yes.
Right. So this is equal to question mark. Now, one by one we will solve. So one by one we will solve. First we will solve for heat exchanger and apply the steady flow energy equation to heat exchanger. So number one is heat exchanger. Can we apply steady flow energy equation to heat exchanger? Yes. So Q dot from 1 to 2 minus W 1 to 2 will be equal to m dot into delta KE plus delta PE plus delta H. For a heat exchanger, what is W shaft work? For a heat exchanger, what is shaft work? Whether there is any shaft work for heat
Zero.
exchanger?
Zero.
Yes,
Zero.
correct. So this will become 0. M dot will be there. What about kinetic energy? Whether the velocity is changing in the heat exchanger?
Sir, kinetic energy 0.
Kinetic energy is 0. Why? Because there is no change in the velocity. If there was some change in velocity, this is 30 meter per second. This is 30 meter per second. And if this was some different value than 30, then kinetic energy would have been in existence. Yes or no? But now as the velocity is same, this will become 0. Yes or no? What about what about potential energy?
Sir, 0 as well.
Correct. There is no mention of change of height or change of datum. So it will become 0. So now our equation will be Q will be equal to Q1 to 2 will be equal to m dot into delta H. And you know the value of delta. What is the value of H? H is Cp into T. Yes or no? So it will become Q1 to 2 will be equal to 2 into, yes, Cp into delta T. What is Cp into delta T? Temperature at the exit and temperature at the inlet. What is the temperature at the exit? That means T2 is how much?
800
So 800
minus
degrees
15.
Celsius. Convert it into Kelvin. (800 plus 273). It becomes 10.
1073.
So it will become 1073 minus T1. T1 is how much?
15. 288.
Yes. So this is okay. So how much is Q1 to 2 now? What answer you are getting for Q1 to 2?
Yes, sir. Same answer.
Right. So it is 1577.85. Is it okay? So we got our first answer. What is the second question? Power output from the turbine, assuming no heat loss. Assuming no heat loss means it is insulated. Turbine is insulated. There is assuming no heat loss. There is no heat loss from the turbine. So Q will be equal to 0. Right?
Yes, sir.
Okay. There is a change of temperature also. So we will now write down Q122 for the turbine. This is for the turbine. Minus W shaft work will be equal to m dot into delta KE plus delta PE plus delta H. Now in this equation, what will become 0? Q will become 0. Why? Because there is no heat loss. What about shaft work? Shaft work will be there. Right? From the turbine, shaft work will be there. That is equal to m dot into whether there is any change of velocity in the turbine.
Yes, sir.
Yes. Final minus initial means 60 minus 30. Yes or no? So it will become C2 square minus C1 square by 2000. It is 2, but to convert into kilojoule, we will put 2000. Plus delta PE is equal to 0 because there is at the same database there. There is no change of height. What about delta H? It will come or not come?
So not come because insulated है.
That is Q is equal to 0.
Sorry.
Ha. So it will become Cp
Yes, sir.
T2 minus T1. Is it okay?
Yes,
Because
sir.
there is a change of temperature is there.
सर 2000 कशात कन्वर्ट केलं आपण?
Kilojoule. Okay.
Okay, sir.
So we will now substitute. So here it becomes 2. 60 square minus 30 square by 2000. 1.005 into what is T2? T3 and T2 it should be actually, है ना? T3 and T2. So what is T3? 650 plus 273 is how much?
923.
Right. So 923 minus 1073 will become this value. So we get what we get. Two into 1.35 minus of 150.75. Is it clear? Is okay?
सर एक डाऊट होता.
हाँ.
तो डिवाइड बाय 2000 म्हणजे
So
rate.
when we put C2 square by C1 square by 2, the answer comes in joules per second.
Okay,
that is
sir.
why we multiply by 1000 here, so that our answer gets kilojoule per second. Because all these values, Cp is also in kilojoule, no?
Yes, sir. Got it.
Right, and this is kg per second. So kilojoule per kg Kelvin. So Kelvin will cut, kg will cut. So we'll get kilojoule per second. So this answer should also be in kilojoule per second, so that we can subtract from these two things. Yes or no?
Yes.
Right. So what is W shaft work now?
298.8.
Correct. 298.8. What will be the unit? Kilojoule per second. This is for the turbine.
सर मायनस मध्ये येणार ना.
So minus and minus of shaft work, and this also minus value, so it
Okay.
becomes
Oh,
positive.
yes, sir, got it.
So you can see W shaft work is the turbine is work producing device. That is why it should come positive. As per our sign convention, we have mentioned here sign convention, no? See here, this is the sign convention. Work done on the system is negative, work done by the system should come positive. Yes or no? This sign convention we are following throughout the thermodynamics. Is it okay? Now
Yes,
the third
sir.
part. Now the third part. We will now calculate for the nozzle. So you write equation for nozzle. Q dot 123 minus W shaft work will be equal to m dot into delta Ke plus delta Pe plus delta H. Whether there is any heat transfer from the nozzle, not given, so it should be 0. Whether any shaft work for the nozzle,
0.
m dot is there. What about delta Ke? Whether there is any change of velocity in the nozzle,
Sir, that we have to find out.
correct. And also, if you remember the definition of the nozzle, it is what? It is used to increase the velocity on the expense of change of enthalpy. Yes or no? So by definition also, this should come and enthalpy should come, and Pe should be equal to 0. So we get 0 minus 0 is equal to m dot into delta Ke plus delta H. Correct? So you write 2.2 into delta Ke, C4 square minus C3 square by 2000 plus 1.005 into T4 minus T3 in Kelvin. Yes or no?
Yes, sir.
So if you substitute C4 square minus, this is how much? 60 square, right? 60 square by 2000 plus 1.005. What is the temperature of outlet of the nozzle?
773 in Kelvin.
773 in Kelvin.
Yes, sir.
Okay. And what is the inlet? 923. Yes or no?
Yes, sir.
Okay. So if you see, and this is equal to 0. So if you see, only unknown is C4. So what is C4 then? Tell me now. So the value of exit velocity from the nozzle is 552.36 meter per second. Everyone got the same answer? Okay, you got the same answer, 552.36 meter per second.
Yes, sir.
Okay, correct. Right. So this kind of questions are asked in the exam. You see, we have taken all three things together for you to understand. There will be individual questions also, just to find out the by applying steady flow energy equation, some parameters will be given, and you have to find out the other parameters. So you should be very careful in putting the units. Always you see this m dot is in kg per second. Kg per second. Kinetic energy is in kilojoule. This also in kilojoule. This also in kilojoule. So kilojoule per second will come. So kilojoule per kg this will be. Okay. And your final answer will be in kilojoule per second. Same time, this other side, which is the left hand side, we should also have kilojoule per second value. Okay. So this you pay attention to. Only sign convention, and we can say that units are very important. Okay. Velocity in meter per second, potential energy in kilojoule per kg. So it is mgh. Okay. So m is nothing, m is coming outside, so it will be g by g into z. Z is reference datum, z2 minus z1. So potential energy, where it will come? It will come for what component? Potential energy will come for what component? For pumps. Okay. Or if that control volume is having some pipeline which is pumping the hot water from lower end to higher end, in that case potential energy reference datum will come. Right?
Yes, sir.
Okay, so let's summarize what we have done up till now. We started with some problems on the open system and closed system. First law applied to open system, closed system. We differentiate. Now you will be able to differentiate between open system and closed system. Open system is what? Where the mass and energy both can leave the system. Whereas closed system is energy can be interacted with the system and the surrounding, but mass cannot. Mass interactions are restricted, energy interactions are possible. Isolated system, neither mass neither energy will leave the system or will enter the system. Then we differentiated between flow and non-flow system, which is our first objective of our course, that students should be able to differentiate between heat work principle and should able to identify or apply the first law of thermodynamics to non-flow system. Okay, so non-flow system means what? It is just a simple example I would like to give you is cylinder piston arrangement is a non-flow system, whereas a tank in which water is flowing in and out is given as flow system. Water flowing through pipe is flow system. Or some mass or matter which is not leaving the system, but there are thermal interactions taking place or thermodynamic interactions taking place, will be called as a non-flow system. For non-flow system, there are 5 cases: constant volume process, constant pressure process, isothermal process, isentropic process, and polytropic process. For all these non-flow system, the work done is given by integral of PdV. What is integral of PdV? Is the area under the PV curve. Is okay? For a constant volume process, work done will be 0. For constant pressure process, work done will be product of pressure and volume. For a constant temperature process or isothermal process, work done will be equal to PV into ln of V2 by V1. For isentropic process, work done will be equal to gamma minus 1 upon gamma P1 V1 log of V2 by V1. and for work done in polytropic process is given by n minus 1 upon n P1 V1 log of V2 by V1. So this you remember, we have solved, try to find out the relation between pressure and volume for the given question whenever numericals are asked. Okay, so we have solved numerical based on first law of thermodynamics applied to open system, closed system, and for non-flow system, and also flow system as steady flow energy equation applied to heat exchanger, nozzle, turbine, compressor, and throttling device. This ends our first module. Any doubt till now? And this is how you have to summarize your first module.
सर
Yes, sir.
ते
Yeah.
मला आहे ना ते झिरो कसे येतात ना आता हे तुम्ही हे के झिरो आहे W0 आहे P0 आहे हे कसं आहे ते नाही समजत आहे मला.
Okay. Whenever the system is insulated, if the system is insulated, heat transfer, this is the Q is nothing but heat transfer rate. Heat transfer rate will be zero. Just think like that. Heat transfer means kilojoule. Heat transfer rate means kilojoule per second. Kilojoule per second कधी येणार? When kilojoule per kg is multiplied by kg per second. What is kg per second? Kg per second is m dot. So if the system is insulated, क्वेश्चन में अगर लिखा होगा कि it is insulated, then our Q will be equal to 0. If there is no moving part, like in heat exchanger there is no shaft, in nozzle there is no shaft, but in turbine and compressor there is shaft. So in that case WSH will come. समझा?
WSH चं काय बोललात तुम्ही?
शाफ्ट वर्क.
शाफ्ट
शाफ्ट वर्क.
शाफ्ट वर्क ना, जर शाफ्ट नसेल तर WSH झिरो असणार.
करेक्ट.
म्हणजे
आपण प्रेशर
आणि
कुकर
म्हणून
गॅस
मग पोटेन्शियल एनर्जी पण झिरो ना, बिकॉज
potential energy when it will be zero, when there is no height factor, when there is no change
हाईट
in the
फॅक्टर
height, then the
आणि
potential energy will be equal to zero. When
आणि
there is no
कायनेटिक
change in velocity, no change in velocity, then kinetic energy will be equal to zero.
आणि डेल्टा जे हे तर डिफरन्स इन काय आहे?
Delta H is difference in temperature. Cp delta T. Delta H is equal to Cp delta T.
ओके, थँक्यू सर.
Understood?
हा.
Q is interaction between system and surrounding. ये आपका सिस्टम है. सिस्टम और सराउंडिंग में Q becomes zero. बराबर? Because it is insulated. Yes or no? बट अगर सिस्टम का टेम्परेचर बढ़ रहा है फ्रॉम 1 to 2, दिस इज T1, दिस इज T2, अगर ये टेम्परेचर चेंज है देन एंथैल्पी फैक्टर विल कम. इज इट ओके?
हा सर. हा.
And if you remember, delta H has close association with delta U. What is delta U?
इंटरनल एनर्जी ना ते
So you see delta H is equal to delta U plus PV. You remember this equation I have told
हा
you?
हा हा
Yes or no?
अगोदर.
So delta H is equal to delta U plus PV. So
ओके सर.
if PV is not there, delta H is equal to delta U, which is given by Cp delta T. Is okay? Right?
हा सर, थँक्यू.
Okay. So we will stop now. We will stop here. I will upload the notes, this lecture slide, also the video.
सर याच्या अगोदरच्या पण.
हा याच्या अगोदरचे पण. Right. Somebody has raised the hand. Any doubt for anyone? Yes.
Sir, what about term test one?
Term test I will tell you. First I will cover up some syllabus. First you solve, I will depend based on your confidence of attempting the questions. Then I will let you know on which date I will take the term test. Most probably it will be in the first week of March. Okay, first week of March.
सर मंडे पासून तर चालू होतं फर्स्ट वीक ऑफ मार्च.
So Friday, Saturday I will keep.
सर पॅटर्न काय असेल?
Pattern is will be the same as that other subjects are following. 50% MCQ, 50% written based.
सर
Yeah.
सर मॅथ्स मध्ये एमसीक्यूज होते आम्हाला.
मॅथ्स मध्ये
जो ओनली एमसीक्यूज होते.
So
Ahead.
only MCQs will become difficult for you. As per my point of view, only MCQ will become difficult for you. Instead of that, if I give you questions, same questions that we are covering in the class, just modifying the data as a little bit will become easy for you to attempt. This is what I feel. We will discuss this in
Yes,
group.
sir.
Okay, we will discuss it. You create a thermodynamics group. We will discuss in that group what should be the pattern of the paper. Okay.
Yes, sir.
Right. Okay.
सर फर्स्ट अँड सेकंड मॉड्यूल येईल ना युटीला?
Sorry.
फर्स्ट अँड सेकंड मॉड्यूल येईल ना